This is the third segment on Newton's laws. In this segment we're going to discuss the third law, and Newton's third law simply states that for every action there's an equal and opposite reaction, or another way to say that is that when object A exerts a force on object B exerts an equal and opposite force back on object A. So when someone pushes on a wall, the wall is pushing back on them. In the image below, if the person were to push against the wall, think about what direction she would move, and you can probably logic through that she's going to move away from the wall, which means that she's going to be accelerating away from the wall, which means there must be some net force acting on her. And where does that net force come from? That net force comes from the wall. She pushes on the wall pushes back on her. Another example of this is in the use of rockets, and this is how all rockets work. Basically, you have some fuel in the rocket engine that's burning, and as it burns, it's this very, very hot gas. These molecules are flying all over the place, and they're exerting forces in all directions on the interior of the container. Some of them are hitting the front, exerting a force forward. Some of them are hitting the top. Some of them are hitting the bottom. And then some of them are coming out the back. And now you'll notice that the ones that are coming out the back, they're just traveling straight out the back into the environment. They're not hitting anything. So that means that there's some net force acting in this direction. There's some net force acting down in this direction. There's some net force acting in this direction. So the molecules are exerting a force forward on the rocket itself. The rocket is exerting a force backwards, causing them to shoot out the back. But because the molecules aren't hitting anything as they travel back out the back, there's no net force acting in that direction, and so the net force acting on the rocket as a whole is towards the front of the ship, and that's what causes it to move forward. Another example of this that we can see is in the firing of a gun. And so here we have a person at a firing range, and he's about to fire the rifle. And you can see quite clearly that there must be some force acting on this guy, because he gets accelerated back very, very quickly. There is a force that the gun is exerting on the bullet to propel it forward out the front of the rifle. Now the bullet doesn't have a lot of mass, and so it accelerates very, very quickly. The person holding the rifle has a much larger mass, and so he doesn't accelerate as much, but you can see it's still pretty significant. So Newton's third law is actually what allows us to walk, what allows cars to drive, because as we're pushing our feet down on the earth, we're actually pushing down and back. There's some friction there. We're pushing back on the earth. The earth is exerting an equal and opposite forward on us, causing us to accelerate in the direction of that force, which of course is forward. And so here's our foot. And so we're exerting force A back on the earth, and the earth is exerting force B forward on us. And so we're actually exerting a net force on the earth while the earth is exerting a net force back on us. So if we look at just the magnitudes the magnitude of force A is equal to the magnitude of force B. The difference, of course, is the size of the mass upon which that force is being exerted. So if our force is force A, the force is being exerted on a very, very large mass, the mass of the Earth, and so it has a very small acceleration. Obviously, it's unnoticeable, it's so small. But force B, which again, same magnitude as force A, is exerted on a much smaller mass, and so you get a larger acceleration, and that's one that's noticeable. We can see it. We walk, obviously that's how we walk. And so even though the forces are the same, the accelerations of the two objects are going to be different, and that's because those equal and opposite force pairs are being exerted on different objects. And that's the key. The equal and opposite force pairs are being exerted the equal and opposite force pairs are acting upon different objects.